So Michelle wanted to investigate the effects on the vertex, and we talked in class that the vertex is a synonym for the minimum or the maximum. So I'm going to make a note, min/max, of the graph, f of x, and remember that f of x, this is just a fancy way of saying y, no big deal. And the graph of f of x is equal to x squared plus 6x. Now, because of the squared, we know that we are dealing with a quadratic relationship, and it is going to be a parabola, which makes sense because we have a vertex, which is a minimum or maximum point. And so we want to find out what happens when f of x is replaced by f of k plus, x plus k. Now, this plus k does something interesting with the graph. It is going to create a translation, which means the graph is going to slide either horizontally or slide vertically. We'll explain in a little bit on what that means. Michelle graphed the functions of the form f of x plus k for k is equal to 1, 2, 3, and 4. For each of the, can you turn off the middle light, please, Anya? Blinding. For each of the functions she graphed, the x-coordinate of the vertex was negative and different for each value of k. But the y value of the vertex was the same for each value of k. Michelle made 3 conjectures based on her results. So now the nice thing about this problem is it actually tells you what happened. That the x-coordinates of the vertex were negative and different. So that means it slid along the x-axis. So if we have a parabola, I don't know, let's say it looks like this, where we have an intercept at -6 here and an intercept here of 0. And just for funsies, let's say that minimum point is -3, -9. That when you plugged in 1, 2, 3, and 4 for k, it made your parabola slide, and it said the x-coordinate of the vertex was negative and different. So this translation was sliding the graph in this way. But the y value of the vertex was the same for each value of k. In other words, it didn't go up or down, it just slid. Michelle made 3 conjectures based on her results. That the x-coordinate of the vertex depends on the value of the k. What this means is if the k value changes, the x-coordinate changes. Well, is that true? If you slide the parabola this way, when k changes, is the x value changing? And the answer is yes. So this is true. Then it said the x-coordinate of the vertex is negative for all values of k. And we'll look at this on the graph. But again, if you only slide this way, the x values will always be negative. So this one is also going to end up being true. And they're trying to trick you with this plus here, and I'll show you why in a second. And then finally, for the y value of the vertex, it is independent of the value of k. That means when k changes, the y value, since it is independent of k, does not change. So if you slide this parabola this way, this vertex is always remaining at -9. Now, the way I found that is I factored the x squared plus 6x, greatest common monomial. So my x-intercepts would end up being 0 and -6. That means my line of symmetry is in between those two, which is -3. So then I plug in -3 for x for both of these, and I get the minimum is going to be -3, -9. I know that was quick, but that's not what the problem was asking. So if I slide it, it doesn't really change, right? So it says determine if each of Michelle's 3 conjectures are true and justify your answer. And so here's the thing. The best way to do this is to look at a graph. So we will. Here is a graph of the function f of x is equal to x squared plus 6. And again, lo and behold, I have my 2x intercepts at 0 and -6. And my vertex, also known as minimum, is at -3, -9. And this handy dandy tool over here is going to allow me to change the value of k. And you'll remember in the problem, k is either 1, 2, 3, or 4. It does not go into the negatives. So let's see what happens. I'm going to use the slider, and I'm going to go to 1. And we'll see, here's our original graph, and our graph now is just slid along, our vertex is just slid along from -3, -9 to -4, -9. And if I continue to slide it, you'll see that my parabola will continue to slide to the left. But the interesting thing is, if I go in the negatives, that's when my k value is negative, I'm going to slide to the right. So when I said they're trying to trick you on staying negative, if you slide to the graph to the right, in other words, have a k value of -4, it's going to go into the vertex is going to go into the positives. But you're not. You're only sliding to the left because k is remaining positive. Now, the interesting thing about this is when you talk about equations of parabolas and circles and all this other stuff, you're going to hear about minus k and minus h. And essentially what it means is you're going to have these translations, and the translations are the opposite of what you put into your equation. So if you're adding k, then positives are going to take you to the left, negatives are going to take you to the right. If you're subtracting k, it'll be the opposite. Now, why does it make sense? Let's go back to this. Why does it make sense that you're sliding along the horizontal axis? And let's take a quick look at that, and then we'll be done with this. We said that f of x is another way of saying y. Well, what's another way of saying what's inside the parentheses? Well, if this whole piece is y, then this little piece here is x. And you know that on a graph, the x-axis determines its position horizontally. So if you're adding or subtracting something to your x value, that means it's going to be sliding horizontally. Likewise, if you're adding something that is adding to your y value, it is going to be sliding vertically up and down. So if you're adding something outside of that parenthesis, then you're going to have a vertical change, not a horizontal change. But it is, again, the opposite of the sign. So a negative h value will make your graph go up, and a positive h value will make your graph go down.